Hello, those of you who've joined already, thanks for joining. We'll be getting started here in just a couple minutes. Hey, folks, again, thank you for joining. I see folks starting to jump in on the attendee list here, so we'll give them maybe just another couple minutes before I jump in here. My name is Brian Jones. I'm the Customer Success Manager for EDX Wireless. And if you're a current EDX user, a current customer, I may very well have talked with you or worked with you in training. And if you're new to EDX and I haven't talked with you yet, I'm sure probably I will at some point. Um, so again, we'll give folks just another couple minutes here. I see the room kind of starting to fill up. Okay, well, it looks like everyone it said was joining. Looks like they've joined in now. So we'll go ahead and get started because I've got a fair amount to show you in the software today, and just a few slides, mostly to sort of guide me as I go along here. Um, and as I'm going along, if you have any questions, go ahead and do use the chat session or there's a Q&A panel there, and I'll try and get to those questions kind of as I get to the end of every section or to the end of the demonstration. And if there's anything that you want to follow up on or sort of ask more detailed questions about, please do feel free to reach out to us either through your sales account manager or just go on to edx.com and go on the support portal and start either look at the knowledge base articles or start a support case with us, and we're happy to talk with you about whatever you're doing in the software and how we can help. So today we're going to be looking specifically at modeling private LTE and our LTE feature set, particularly for utilities. Utilities have a really wide variety of telecommunications use cases, and those needs are growing all the time from mobile voice and data, push to talk radio and even vehicle mounted radios and data radios and that kind of thing. Backhaul planning, of course, distribution automation, whether it's SCADA or being done through private LTE or another technology. Um, all of those sort of fixed point to multipoint types of networks. And then, of course, smart metering AMI can be a category and a topic completely unto itself. But of course, it's, for a lot of utilities, it may be the same planning department that's handling all of these things. And then I've got route-based planning there with a question mark because of course route-based planning can be along the terrain as you see here. This route is a vehicle sort of descending down into a big canyon or a pit and showing real precise coverage along that. But one of the topics that we've talked about, and I think I've brought this up maybe in other webinars as well, is the potential to do route studies at elevation. So you can put a flight plan in. And so if you're looking at drone inspection for power lines or other assets, that kind of thing, and you find yourself responsible for guaranteeing communication to those drones as they go out along your lines. That's the kind of thing that we can actually handle in Signal Pro as well. Um, so there are a few sort of places I want to drill into Signal Pro and show you a couple of examples that I've set up in the software, just to kind of give you an overview of how you might go about setting up your own private LTE network in Signal Pro, and maybe show you some tips and tricks and ways that you could configure things to support some of the more complex use cases that we're seeing and that we're hearing about. Um, so first things first, I want to give you a nice sort of clean overview of how you would set up the LTE technology and the LTE studies in a Signal Pro project. Um, and just take a few minutes to go through that as kind of a quick overview. Um, whether you're a beginner to Signal Pro or already a Signal, an experienced Signal Pro user, hopefully this will be kind of a useful review. So looking at my project here, you may have seen this project before in other webinars, and I'm going to go ahead and just uncheck some of these layers and hide some of my completed multi-point study results here um, to get back to a sort of base project here. So of course, like any other project, I'm going to set up my terrain elevation data set, my land use, land cover data. In this case, I'm using our Cirrus subscription clutter data. So this is a hybrid 5 meter clutter data set. And, going down the checklist here, like I do, I would set up the propagation model. In this case, we're using the Anderson 2D with clutter pass-through loss. And I've included in a little bit of extra fading variability path loss as well, just because I want these to be, really highly reliable links in setting up the base station equipment. So in my transmitter base sites category here, here's where I want to set up what my typical eNode B is going to look like. And I've gone into the template here. And in this example, I think we're looking at band 8. And so I've set up a 900 megahertz site. In this case, I did just one sector. If you had, and I've set this up as an Omni, if you had a more typical sort of 3 sector configuration, then you would put three of them here and put a directional antenna and all that kind of thing. I'm sort of keeping it simple in this example here, so I've made just Omni 900 megahertz sites, and of course under transmit parameters, I'm going to set up my uh, height, directional antenna, all that kind of thing. Same on my receive parameters. And then crucially, when I get to the system name slash type here, I want to select the LTE Pro, which is our current revision of the LTE feature set and is up to date. And when I set this LTE Pro system name or type, then that means I want to go and define the LTE band and configuration details that I'll be using in this project. And that would be the same if I was using, another technology. If I was using NB-IoT, I would select that system type, and then I would go and, set up the details here under NB-IoT and technology profiles, or LTE-M, or, whatever flavor of the 3GPP standard you're using for your use case. You would set these all up the same way. So in my case, I've done a standard band 8 LTE because I uh, want to be able to run a variety of use cases on it. And so what I would do first is go into technology profiles here, and as my default profile, I went ahead and just set up band 8. And when you select a band here, it's going to automatically give you the options for channel bandwidths that are allowed under the standard for that band. And then your spacing and cyclic prefix, whether it's TDD or FDD, is going to be automatically configured for you. And so you can set up just one, and it'll automatically be used as the default for any LTE sectors that you create. If you're doing something more complex where you have a couple of different bands that you're working with, then you would go ahead and add some more rows into the table here. And when I go to set up my sectors, or after I've added my sectors into the project, then I would want to come in and define which band each sector is using. And, of course, we can do those by groups, and there's a variety of ways to get those assigned. Again, to keep it simple, if you're just working with one band, you can just set it as your default, and they'll automatically be assigned that way. And then if I'm setting up to run a mobile or area study, so coming back to our slides here, we had looked at mobile data and voice. Now, if I want to do sort of area-wide heat maps for coverage, I went ahead and set up a mobile remote unit that you notice this second mobile type I have set up is just a mobile at 1 meter above ground level. And I probably could have included some obstruction loss, some body loss or additional clutter. Maybe I would do that. Um, but then importantly, this is a new item in the Signal Pro user interface. You'll notice there's a place to check on if this is an LTE subscriber device or an LTE mobile, then we want to check this use UE category and select the UE category type that we're using. Because, depending on the category type, it'll have different data rate constraints and be allowed different MIMO types and things like that. And so it's important to make sure that if you're running any of your area studies and also doing traffic loading, you go in and set that UE category. Um, if you are going to do carrier aggregation, and this might be a little esoteric for most utility type use cases. But if I'm using carrier aggregation and I have a couple different bands, then I can put the carrier aggregation code in here as well. That's not required though, if you want to just do a single band for any one mobile, then you can just set up the UE category alone. Um, if I'm looking at fixed subscribers instead, which in this case, all of these little yellow dots here are my what we call a CPE, or customer premise equipment, customer terminal. And here on the new CPE button with this little drop down, I can go ahead and set up CPE types where if I'm looking at distribution automation assets, so switches and reclosers up on the tops of poles, I can put the top of the pole height that I want to use. And this is just the default, by the way. You can input, as you import these locations, you can input different pole heights for, different categories of poles that you might have and that sort of thing. And then down here under traffic, importantly, I can give an average traffic demand for this type of fixed subscriber. So if I have different kinds of assets in the network with a different traffic demand, maybe a different schedule that they get messages or that kind of thing, then I can set up different CPE types and assign those to the different asset types as I bring them in. And then this activity factor is essentially how often we can consider this radio to be active and making that traffic demand. So this essentially is going to scale it. You know, if I'm asking for 1 megabit per second right now, and I put my activity factor to 50, well, then it's asking for a half a megabit per second. So that's when we go to look at the traffic loading, that's how that's going to work. So I can set up these types for the fixed subscriber devices, and then under my spreadsheet editor, I can go ahead and import all those devices. And in this case, uh, I know all the customer locations, but perhaps I don't yet know where I should set up the eNode Bs in order to best serve all of these end devices, especially considering their capacity constraints. So, what I can do in that case, if I'm using the LTE module, I can run either the auto placement for areas, in which case I would give it just a polygon and say this is the area I'm trying to serve, or if we have these fixed locations that we're trying to serve, I can go under multi-point backhaul networks. And because you've got the LTE module, this create hub and transmitter group function will allow you to use automated router selection. And there's a few setup things that you have to go through here to set up your propagation model and things like that. But ultimately, um, this method number 4, capacity planning with local greed, is a really sophisticated auto placement that can take into account both the tower heights and their relative costs and the capacity constraints on those eNode Bs so that you can have it in one pass, evaluate the coverage footprint of every possible candidate and give you a suggestion for an efficient way to cover, whatever percentage of the subscribers you need to, 95 or 99% or whatever. Um, so with that automatic site placement for multi-point, I went ahead and created these sites that I can then run either my point to multi-point studies for, and that's my RSRP, and if I show my CPE to hub links here. So uh, once I have set up the equipment and the technology and I have those site locations, I've gone into multi-point studies here and set up the different study criteria that I want to see. And again, if you haven't used them before, these are located in the LTE Pro study group as you're setting up a study. And it would be the same way if you're doing an area study or a route study or whatever. Just make sure you choose the LTE Pro study group, and then here's where you'll find your throughput in megabits per second, RSRP, RSRQ, cell edge coverage, etc. And there's some additional study types coming soon that'll be added to the list as well. We'll have a little roundup of coming soon features at the end of the session here. Um, so at this point, once I run my different studies, then I can go ahead and look at individual CPEs and say, well, why does the CPE have marginal results? And I can look at that path profile and see, oh, well, that hill and the trees at the top of the hill are why. Um, and maybe make some decisions to sort of finalize that design. And then once I'm locked in on my site placements and all of that sort of thing, Then I'm ready to go again into the LTE Pro Networks menu and do my PCI physical cell ID planning, which this is very straightforward. If you have any excluded PCI codes, maybe that you don't want to use them because a neighboring utility is using those codes and you're trying to coordinate, then you can go ahead and put those excluded PCIs in here. And when you click run, it's going to go ahead and suggest those codes for PCI and PSS and SSS. And you can see I've already done that here, and I've got those and can export those. And then I can do the same thing for neighbor lists as well. I can go ahead and go in and run that neighbor list and export those. And at that point, I've got sort of a finished simple case design. And so let me jump back to my slide here and just review. So we set up our site template using that LTE Pro system type, and then we set up the technology, the band we're using. The automatic site selection can choose site locations for us if we need that. Um, and if we're using more than one band, then we can assign those bands to our sites independently, or just use the default. Then we go ahead and run our studies, finalize the network design, and run PCI planning and neighbor lists. Um, and so that's the overall process. And again, if any of that's unfamiliar, you're just digging into using Signal Pro, there are some knowledge base articles about how to set this up. If you go onto edx.com and go in the knowledge base, so you can have a guide sitting there in front of you as well as you go through it. And feel free to reach out if you have any trouble. Um, let's talk about traffic and redundancy and reliability. And we'll look at a couple features, and also I'll jump over to another study to look at a common use case. So in general, if we're planning just a greenfield brand new network that's going to have very little traffic on it, we can plan for just coverage. An RSRP coverage prediction would be perfectly sufficient uh, to show, what endpoints we can cover and all of that. As the network gets more heavily loaded, then we might start to run into problems where even though we have coverage, if the signal quality is being degraded because of noise rise, then performance can start to fail. Um, and that's the noise rise table that you see over here. If I go into Signal Pro and look at my receiver properties, and this is on the base station or the mobile or what have you. If I check on this use load-based noise rise, and so I want to check that on in the site template itself. If I'm setting up a project template for LTE, I'll just make sure this is on all my site templates, and then I can forget about it and not have to think about it ever again. But what it's going to do is make it so that for each sector, we're going to look at how heavily loaded that sector is in terms of the amount of traffic demand on that sector. And based on how much bandwidth, how much spectrum is available at that sector and how heavily loaded it is, it's going to start to account some load-based noise rise. And this table is from the 3GPP standard. If you wanted to adjust this table because you're trying to be more conservative or what have you, you can, but the default table is from the standard. And when this is on, then of course by default we're not going to have any traffic loaded onto this, and we can load that traffic up either from a fixed multi-point network, the way we've got here, and this is actually a feature that is just about to change if you look in your very latest version of the software, there's a new 3GPP traffic loading feature, and the multi-point traffic loading is just about to get shifted over into that. Um, so in this dialog here, under the traffic options, we'll have a multi-point distribution as well. In your current version of the software, the way it works is under my traffic modeling, it's under the non-3GPP traffic loading at the moment. It doesn't actually make a difference. It's not gonna change your result at all. But if I choose this multi-point traffic from CPE, and then of course I would choose my group and the study that I want to run this against. So I would choose, my RSRP or my downlink throughput study, and based on the coverages established in that study for each fixed CPE location, when I click calculate average traffic load on each sector, it'll go ahead and load those traffic values onto the sector. And then also it'll save me out this multi-point or this text report that shows how much uplink and downlink traffic demand is being placed on each sector and how many CPEs and all that kind of thing. And so by loading up that multi-point traffic onto the sector, then that load-based noise rise is going to be taken into account in the signal quality calculation, and therefore your throughputs and things will change. And if you've got a sector or an area that is overloaded, you'll see that in the performance degrading in that location. And you'll see it as well if you add another sector that can take up some of that area, then or take up some of those fixed CPE locations and take their traffic, then the performance can improve there. So that's the traffic loading and noise rise, and it's important, I think, if you're looking at how the traffic load may impact your network, and use cases we're hearing about are, well, we want to run the distribution net, automation, the fixed multi-point network on our private LTE, but can we also have mobile radios on there, mobile data radios, or can we also load our AMI onto there? How much can we put onto the spectrum that we have before things start to go badly? And that's exactly what this noise rise and traffic loading function is designed to help you understand. Um, Another study type that I want to show you, and this one's just an easy way of looking at redundancy or reliability in the multi-point network. I think that I have run this. Yeah, I have. Um, the number of servers at remote study, if you establish in your CPE type, if you as you're setting up your fixed subscriber, if you establish a minimum received power for acceptable connectivity, that threshold can be used to count how many base stations can be heard by this remote, or vice versa. Of course, depending on how you establish that threshold, you want to make sure you've got uplink as well. But if I go ahead and look at this, any any one CPE, any fixed location that has only one server, that means that if that server were to go down, we wouldn't be able to communicate with those CPEs at all. And so ideally, if we're trying to get redundancy across the whole network, we would distribute a few more sectors, a few more eNode Bs, I should say, into the areas where I'm seeing this yellow and orange, where I've got a bunch of endpoints that only can communicate with one eNode B. For those locations, if we were to go in and put in a few more eNode Bs as sort of backup, some that have good connectivity around, then we could try and get to a point where we've got 95 or 100% of the network at a full eNode B redundancy or full base station redundancy. And then another redundancy use case that we've been asked about and that we've seen folks looking at is to look at the possible connections between these base stations. So whether we're talking about LTE equipment or the GEMDS equipment or what have you, oftentimes if the backhaul fails for one of these sites, it can potentially store and forward its messages through another site, especially if we're setting these things up for distribution equipment. Very often they have a store and forward capability that if you're already a user of our mesh module, you have some really powerful tools for looking at the interconnections between your existing sites. And so I'd like to go ahead and show you that. I'll just save this project just like it is so I can come back. And I'm going to jump to this small scale mesh for utility backhaul. And this should look really familiar. I've got the exact same multi-point network here. So, here's all my oh, wrong study. Uh, all of my CPEs. Oh, that's right. I took them all. I took my multi-point studies out of here so I could simplify it. Um, but so here's the coverage footprint of each of these sites, and they're each covering either fixed or mobile subscribers. But if I want to ask the question, which of these eNodeBs would be able to forward data through its neighbors, or which of its neighbors would it be able to communicate with? As you can see from this matrix, that's a lot of possible point-to-point links. And so again, I'm using the mesh module here. And what I've done is just go in, and this is why I made a copy of the project, is because I changed the system type just temporarily from LTE Pro to the mesh system type in order to use our small scale mesh studies. And now, importantly, the small scale mesh studies, they really only scale up to the level of hundreds or maybe a few thousand mesh nodes before things can start to run pretty slowly. But up to that point, what they can do is allow you to establish a threshold for connectivity and then show every single possible interconnection between all of your base stations. And so if I want to look at the connection between this 2238 and this 2275 all the way on the other side of the valley, I can just right click on these link lines and show that link study. And of course, this study also generates a mesh geometry report, which gives all of these possibilities and stuff. But the way that I set this up, again, I go in and set those system types as mesh. And then under small scale mesh network, I had to point to my channel plan file here and my service area file, which is just the polygon of the area I care about. And then under small scale mesh studies, you can go in here and there are two really important study types. The node to node links. This will just look at what links are possible between whichever transmitter group you have in the mesh layer TX group. So I've said my master transmitter group, show me all the possible links between all of these base stations on the project. And I established the threshold, and this is just RSSI received power. And when you run this or hit this start study, it very quickly produces all of those possible links and displays them on the map. And you can go in and look at any of these as an individual link study again. And you can also adjust that threshold and see kind of quickly at what point some of these links would start to fail out. And of course, I can display these by their path loss as well. But the other study type I'd like to show you that I can display these side by side. If I go to the links and routing, then what that will do is it allows me to set up a gateway. And you notice how the label the label on this site here is green. If I go in here and look at this backhaul selection, if I make a backhaul selection of any kind here, then this gets treated as a backhaul for that small scale mesh. And what the links and routing study will show, or the mesh routing study, here, let me go in and run that now. It'll show the hopping path for all of those devices. If they're trying to get back to the the collector, the gateway back home, then it's showing the least hops path that would get them connected here. And so these orange links are showing where it would take actually 3 hops. And I made a really inconvenient collector here right out behind a hill on the end of the peninsula. If I made a little bit better collector, maybe we'll say this one here. I'll go in and give it a backhaul selection. And if I go and run that links and routing again, you can have as many collectors as you want, and they're just going to try and find the least hops back route back to a collector. Oh, and nobody wanted to jump to this 0067 collector anymore. It's just on its own backhauling itself. Um, so if you're already doing AMI with our Mega Mesh feature, you can probably tell this is a really, really simple way to just look at the interconnections between these sites, which we could also do in our Mega Mesh tool, but it would take a bit more setup and it's not quite as streamlined as this. So if you're just looking at, which of my base stations can connect and let's establish that geometry and how many hops out from a real backhaul location am I? That small scale mesh study is actually a really, really useful tool. And if you've got your mesh module, then you've got that small scale mesh study as well. So I will jump and look at one other mesh feature before the end here, but let's talk about metering and where metering fits into the LTE, or where LTE fits into the communications portfolio in regards to metering for a lot of utilities. We've talked with a lot of customers both on the equipment side and the utility side, and I think the one takeaway that I've had is that AMI 2.0, or the next generation of metering, is not going to be sort of one type of technology, one deployment that's the same across the country or internationally. Really, different utilities are coming up with different solutions and different ways to fit private LTE into that solution or fit other technologies into that solution. Um, and especially depending on what type of utility and what type of metering we're talking about. The electric utilities may have a different solution set entirely and a different set of goals from water and gas or combined utilities. So we're seeing a lot of different combinations of technologies, which of course SignalPro is really well set up to allow you to look at any of these different technologies and oftentimes within the same project. So there's a couple use cases that I'd like to point out and a couple of features that are helpful for this. And first, let's talk about what I would call the most typical AMI 2.0 solution that we've seen. And that's where utilities that already have a 900 megahertz mesh metering system deployed, or in some cases, a point-to-multipoint metering system deployed on the 900 megahertz. They may be adding private LTE, maybe in some other band, and they don't necessarily want to give up the existing network that they have. And so what they're looking at doing instead is densifying the collectors to support more reads per day and more data going back and forth with the mesh radios. And in some cases, that means they're not even putting collectors up on poles anymore. They can put a card right into the meter that can act as a collector for its neighbors on that 900 megahertz. And they have a very low cost infrastructure for still gathering and collecting all of that metering data together. And then those collector points for the 900 megahertz AMI become end devices contributing data into the private LTE network. So the LTE is used for backhaul as well as whatever other applications. Oh, I just lost my user license. Give me one moment. And actually, I need to open my other project, so I'll just reopen the software real quick. See, there's a oh yeah, there was one question in the Q&A that is can we share the recording and slides for reference and yeah, I think there will be a recording of this that they'll be able to share with you. Um, Okay, so I've got my new project open here, and this again is the same point-to-multipoint LTE project that I started out with. So this is the same project where I was doing distribution automation on my private LTE. And let me just hide all my AMI mesh stuff. And what I've done, if I've got an existing point to multipoint distribution automation project and I want to say, can I add my AMI collectors in as endpoints on this AMI or on this LTE network? Well, then what I went ahead and did was to first model out the AMI mesh. So if I go ahead and switch to show my AMI collectors group, here are all of the collector sites for that 900 megahertz AMI mesh. And of course I used the automatic placement to get those. And the actual smart grid meters, I went ahead and imported those in my Mega Mesh tool. And so I can see the AMI mesh results here. And in a densified uh, mesh network where we've got, especially with these extremely low cost collectors, there are enough collectors that every meter might only be one or two hops or a direct connection out from a collector. And so you don't see a whole lot of meshing happening. I'm not going 8 or 10 hops out unless I'm in a really rural network area. Um, but using our Mega Mesh tool, I can go ahead and model all of this out with the capacity constraints that I want for the number of messages per day I'm going to have and all of that kind of thing. And then I went ahead and took all of those collector points and I import those as CPE locations. So I just went in and, well, first I create a CPE type for my AMI collectors. It's got the right height and link budget and all that sort of thing. And then under spreadsheet editors here in CPE data, I created a group called AMI collectors, and I go ahead and import all of my collector site locations now as endpoints for that point to multipoint network. And when I run my multi-point studies, I can have that look at either just the distribution group of CPEs or just the AMI or both of them combined, just depending on how I set up the groups. And so, based on that as well, if I do the multi-point traffic loading, then I can see how that load may impact the performance of the LTE network. And that was one of the really crucial questions in looking at this solution that both, utilities and the equipment vendors alike were asking the question, well, what's the most efficient use of our private LTE spectrum, and can we get the AMI onto it? And typically the answer has come back that we would not want to put every single last meter onto the LTE network, but if we put the collectors for our existing 900 megahertz on there, or rather 900 megahertz mesh, then the traffic is supportable. So that's a really interesting use case that, of course, Signal Pro can support from end to end. Um, if you are doing a really massive point-to-multipoint network, so if there's no meshing, no store and forward hopping or anything like that, and but nevertheless you have hundreds of thousands or millions of mesh, or rather metering points to look at, then this area study queries by point feature is a really, really fast way to essentially get point to multi-point results with only having to run sort of an area coverage map. So if I've got my RSRP area coverage study here, I'll hide the smart grid layer. So if I've got my area study of RSRP and I want to do a query against a whole huge number of endpoints or against all the CPEs in my project and say, what's the area study result for that fixed location? Then there's a really easy item here under query, area study queries by point. What you can do is either choose the individual study that you want to look at, or you can, run the query for every area study that you have set up. And then I choose my list of points. And in this case, I can just use the CPE group for those endpoints that I already have set up. Or if I'm doing Tokyo and there's 2 million endpoints in the list or more, then I can just point to a CSV file that can be absolutely massive of lat long locations. And this will go and look up those locations in the area study and create all those exports based off of, again, just one or all of the area studies. And that's been a huge time saver for some of the folks that are doing multi-point, but they're doing really, really big multi-point. So I wanted to show you that feature in case it was relevant for anybody. Um, Oh, and finally, the traffic loading, that just to review again, um, when when we're setting up the traffic on the sectors, we can set that up based either on the fixed point to multi-point, or I didn't actually show you the dialog before. Here under the 3GPP traffic loading, what we can do is if I say that I want to distribute users based on the clutter, then under my clutter details here, I can set up the number of users per square kilometer that I want to have of each user type. And so I could have, and this is again for a mobile use case. If I say, well, might have 10 people out in the field drawing this many megabits per second, what's that going to look like? Um, you can do these kind of average traffic assignments to get an average traffic load for an area mobile type network. However, there's a much more sophisticated Monte Carlo analysis coming soon where you can play around with how those mobiles are distributed and where they are, and show them moving around and all that kind of thing. And that kind of brings me to the coming soon roadmap items here. The LTE Pro feature set is by no means finished in its development. We're releasing new studies and new feature sets for this with almost every release. And coming soon in the near future for the LTE module and feature set. Again, we've got a Monte Carlo traffic analysis that's going to have a dynamic environment with the UEs moving around, and where we're modeling the actual services and bearers. So you'll model the types of service on the network, and it'll be modeling the bearers and actually kind of setting up the frame essentially, so that we've got a really in-depth, sophisticated LTE Monte Carlo, and that's in development. The ACP automatic cell planning, this is going to be an add-on module that's an automatic optimizer for choosing antennas, choosing antenna heights, transmit power, all of that kind of stuff. Right now, we have automatic site selection, which will choose the tower locations, but that's just based on one fixed configuration. The automatic cell planning is going to come up with an overall network configuration design. Um, and so that, especially for large, complex networks with a lot of antenna options and things like that, that'll be a huge time saver. Um, we have further enhancements for the LTE-M and NB-IoT. Currently, they're almost identical to the LTE Pro feature set for mobile LTE, um, but there's a few special features that we're getting ready to release about those as well. And we're also enhancing support for MIMO and doing some deeper MIMO calculations. So I'm sure as those features come out, keep an eye out. We'll have some more webinars and we'll be pushing some more information and instructionals out about those soon. Um, so that's what I have for you today. If there are any other questions, please use the Q&A panel there, and I'll take a look and try and address those. Or again, we can reach back out after the fact. Um, yeah, yeah. There's one good question here about the ACP feature, and you'll have to forgive me. I haven't been that closely involved with the development of it yet. Um, but my understanding the question is, can you add criteria like RSRP, SINR, etc., and can you also tell the tool not to place based on clutter types? In other words, don't put a site in the water. Um, really good, important suggestions. And I believe that, yeah, in our discussions of the feature set, it does have all of those kind of practical constraints and limitations that you can set so that what it tries to give you is a workable design. Um, and that's great feedback. I'll take that back to the dev team and make sure that we plan on having those included in sort of revision one of that feature set. Are there any other questions? Again, feel free to use the Q&A panel, or I guess I can check the chat panel as well. I'll give folks a couple minutes here in case anyone's feverishly typing. Okay, well, if there are no other questions today, then again, thanks a lot for attending here today, and I hope you learned something useful. If there's anything else you'd like to know, please feel free to reach out to us again through your sales account manager or through the support portal. Um, and especially here, I'll go ahead and show that since I'm talking about it. If I just go on to edx.com, if your company has a license of the software and you're not sure if you have an account on here or whatever, it's totally fine. Just go into support, and in the support portal, as long as you've got a company email, you can create an account on here, and that'll give you access to our knowledge base, and you can keyword search the articles there, or you can put in a customer support request. So if you're using the Signal Pro software at all, please do feel free to reach out to our support team, uh, and or make use of that knowledge base. Um, and so one way or the other, we can help you get the best out of the Signal Pro software. Um, so thanks again for attending, everyone, and I hope you all have a great day and a good weekend. We'll talk to you soon.